Okay, welcome back. So in that last video on intervals of convergence, we talked about some of the kind of the main cases, normal cases. Let's talk about some weird cases here. Some of the weird things that can happen. So we're going to talk about some special ones too. So suppose we have the sum from 0 to infinity of x to the n divided by n factorial. And I ask you to find the interval and the radius of convergence of this guy. Okay, now, like usual, we're going to go ahead and set up the ratio test on this. So we'll set up our limit n goes to infinity. We have x to the n plus 1 over n plus 1 factorial times n factorial divided by x to the n. Well, and we want that to be less than 1 because we're trying to find an interval of convergence. So once we get to this guy, as usual, we want to go ahead and put our like terms together. So we have x to the n is x to the 1, that's x to the n plus 1, times n factorial over n plus 1 factorial. Now, you've done these simplifications dozens of times by now. You know that the x to the n's cancel. You know you can write this. Just go down, step it down by 1, n plus 1 times n factorial. These cancel. So when you look at what's left, you're taking a limit as n goes to infinity of x over n plus 1 is less than 1. Now look at what's going to happen when we take a limit. Something weird is going to happen here. So we're going to get x over infinity is less than 1. But what is x over infinity for any real value of x? Well, any number over infinity, because it's a number, you can't have infinity, that's not a legal x value, it's not a number. But any number over infinity is 0. So what you're kind of asking is, for what x is 0 less than 1? So what are the x values that make 0 less than 1? Well, all of them, right? No matter what x value you pick, 0 is always less than 1, right? Any number over infinity is going to be less than 1 no matter what you pick. So what that means is this series converges for all x. So that means that your interval is all the x values from negative infinity to infinity, and it means that your radius is actually infinite. So no matter what number you pick for x, this series will always converge, which I think is kind of cool. If you're curious, by the way, this series adds up to e to the x, no matter what x you choose. That's kind of cool. We'll prove that in the next chapter. But that's irrelevant for now. I was just telling you for fun. Anyway, so what I was saying is that series converges no matter what x you choose. This series will always be a convergent series. That's what's going on there. Okay, let's look at one other funky case. So let's suppose now we have the series 3 times x, oh wow, bad handwriting there. So 3 times x plus 1 to the nth power times n factorial. Well, again, let's set up our limit n goes to infinity. So we're going to have 3 times x plus 1 to the n plus 1 times n plus 1 factorial over 3x to the n over n factorial. And we want that limit to be less than 1 because we're doing the ratio test. Okay, so the 3's cancel. This is n plus 1 times n factorial. I've seen that trick a million times. So this is the limit n goes to infinity. I forgot an x plus 1 down here. That's pretty stupid. Okay, so you're just left with those cancel, so you're just left with an x plus 1 times an n plus 1. Okay, and we're kind of saying what happens, what are the x values that make this limit go? So what you're going to do here is you're going to take the limit. So as you take the limit, you're going to get x plus 1 times infinity is less than 1. So you're going to get infinity is less than 1. So again, we're kind of saying for what x is infinity less than 1? And the answer, I think, is none, right? Like that never happens, except one case. And what is that case? What is the one x value that can make this converge? Well, what if this was a 0? So except for if you had x plus 1 equals 0, so except if x equals negative 1. Which is the dumbest possible case, that if you were to plug that in here, you'd have a 0. So you multiply that out to be 0. So in this case, your interval is not an interval convergence, it's just a point. So it only converges at a point, x equals negative 1. And what that means is you have no radius, right? There's 0 radius. So this is a really stupid series. It is saying this series only converges in the most trivial case when x equals negative 1. I think the case before this was super exciting because it converged for anything. The possibilities were limitless. But in this one, there's only one point that makes it converge. That's kind of dumb. Anyway, I just wanted to show you that. We're not going to see this a lot, but I think it's worth seeing once. The case where you have an infinite interval convergence, this is going to happen quite a bit more often, and we'll work with that a lot, actually. Okay, the only other case I want to work with is what happens if you have an x to the 2n or an x to the 3n, because something a little weird is going to happen here when you do the ratio test. So let's suppose you have this series, and again, we're going to be trying to find the interval convergence for x to the 2n over 4 to the n times the square root of n. And I'm going to ask you to find the interval of convergence. Okay, so we're going to take a limit as n goes to infinity of, all right, so when I plug in the n plus 1, I'm going to replace all these n's with n plus 1s. But we want to be really careful because this is still multiplied by 2. So it's x to the 2 times parentheses n plus 1 divided by 4 to the n plus 1 times square root n plus 1. And I'm multiplying that by 4 to the n times square root n over x, over x to the 2n. Okay, and I want that limit to be smaller than 1. Now, let's distribute this out. And be careful here. This is crucial here. We got to make sure we distribute this guy carefully. Because that's going to become x to the 2n plus 2 over x to the 2n. We have a 4 to the n over a 4 to the n plus 1. We have a square root n over square root n plus 1. Okay, let's clean this up a little bit. So when I work this out, that's going to be what? So I have x to the 2n times x squared on top. So we'll cancel those out. We'll actually get an x squared here. Here, this is a 4 to the n times a 4 to the 1. So those cancel. We're left with a 1/4 on bottom. And then a square root n over n plus 1. So be careful, this distributing leads us to an x squared in this case. So now when you go ahead and take the limit here, you're going to get x squared over 4, and this limit, of course, is the same. It's infinity over infinity, so your leading term or L'Hopital just goes square root 1 like always. So you get this case, so you get x squared over 4 is less than 1. Now, there are a couple different ways that you can try and handle this. The easiest thing that I would recommend is to take the square root at this point. Don't try and split it up first because you might get something weird with a negative. But take the square root at this point, once I've taken the limit, and then we're going to leave in the absolute value. So I'm going to take a square root of both sides. The absolute value stays in because of like the plus or minus from the square root. So we're going to leave that in. So that's saying that x, okay, we take square root, x squared is x, the square root on the bottom is 2. X over 2 is less than 1. Square root of 1 is 1. Okay, so that means that my negative 1 is less than x over 2 is less than 1. So that tells me negative 2 is less than x is less than 2. So if you get to this case, again, just take the square root or take the cube root if it's like an x cubed type case, and then leave the absolute value sign in because we're going to handle that down below. Okay, and now to finish this problem, let's go back and just check the endpoints. So when I check the endpoints again, I'm going to plug back in the original equation like always. Plug back in the OG series and then ask, does it converge or does it diverge? Okay, so when I plug back in x equals negative 2, so let's go back to this series. This series was x to the 2n over 4 to the n. Okay, when I plug in negative 2, I'm going to have a negative 2 to the 2n over a 4 to the n times a rad n. So negative 2 to the 2n is a negative 2 squared to the nth power. So negative 2 squared is positive 4. So that's 4 to the n over 4 to the n rad n. Those cancel. So we'll just end up getting 1 over rad n. This is a p series. My p is a half. I know that it diverges. So I'm going to chill with the negative 2. When I plug in the 2, I'm going to get 2 to the 2n over 4 to the n times rad n. Again, I'm using that same trick, right? 2 to the 2n is the same as 2 squared to the n. So this is 4 to the n over 4 to the n rad n. Bam, bam. So this is just 1 over rad n. That's a p series. Again, it diverges. It's literally the exact same series. So neither endpoint works. And you're going to get some case on the homework where both endpoints work. And it's totally just like, this is what happens. Sometimes it's both, sometimes one, sometimes neither. But you got to check them all no matter what. And I'm trying to model for you what your work should look like on the AP test. You're writing out the limit. You're taking the square root. You check these endpoints both explicitly. You talk about why they converge or why they diverge. And then give you your final answer here. As for the radius of this is obviously going to be 2 because your center is 0 and you go 0 to 2 is 2 points in either direction. Okay, that's my interval, that's my radius. That's the x squared case and some of the weird cases. Thanks for watching, guys, and I look forward to talking about this with you in class.